Hey guys, good morning. How's it going? What I want to focus on today is factoring quadratics or trinomials. In this case, when a is equal to 1. So let's start right there with what exactly that means. How do I make this a little bigger? Okay. So for number 1 here, you have 3 terms. You have what's an a term. Oh, Jesus. We have what's called an a term, a b term, and a c term. In this, you know what, let's start with number 3, actually, and I'll explain why in a second. Okay, you have 3 terms. You have an A term, a B term, and a C term. What A, B, and C are is they are the coefficients. They are the numbers that go here. Okay, it's pretty straightforward. Whatever comes in front of your variable. So here I have an m squared, right? Now we don't write it, but we know from being in algebra there's a 1 there, right? It's 1m squared, right? We don't write 1 because it's redundant. So b term is equal to 1, and my c term is equal to negative 90. Okay, so just to show you guys a few more of these, okay, here my a term is equal to, again, 1, my b term is equal to 4, and my c term is equal to negative 12. So again, something just about everybody can do. Again, what's my a term? Okay, well again, it's 1. My b term is negative 10, and my c term is equal to 9. So when this problem says a is equal to 1, what it means is your coefficient in front of the first variable, b squared or x squared or n squared, is going to be 1. Now, the reason I kind of skipped over 1 is I don't want you guys to get confused about what's what. This b here means a different thing than the variable here, okay? So here a is 1, b is 8, and c is 7. For this one, a is 1, b is negative 11, and c is 10. Why is this important for us? If a does not equal 1, okay, look, a is equal to 1, 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 a is equal to 1. If a does not equal 1, then we have to use a different method. Typically, if a does not equal 1, we're either going to use a different method that we know. Typically, what it means for us is that that example for us won't be factorable. Now, if a doesn't equal 1, it can still be factorable, but we cover that more in algebra too. So it's not something you guys really have to worry about right now. Okay, so the first step to any one of these problems is seeing if a is equal to 1. If a equals 1, then we can continue. Okay, all right. Now, if a is equal to 1, then we can start saying some things. We can start saying, hey, what is my c term equal to? Well, my c term is 7. What I want is I want all the ways I can multiply to make 7. Well, there's 1 times 7, right? And don't forget there's also negative 1 times negative 7. So the question is which of these sets do you want as your factors? And why are we choosing these? Well, you'll see in a second. We want the factors of this number, the factors of the c term that add up to our b term, okay? So the a term tells us, hey, we can keep going. The b term is, the c term is going to tell us what numbers are we factoring, and the c term, and the b term rather, is we want to know which set of our factors add up to our b term. So if we think about this, well, 1 plus 7 is 8, and negative 1 plus negative 7 is negative 8. We want the ones that add up to 8. So we want 1 and 7. What that tells us is if we rewrite this as x positive 1 and positive 7, okay, this is a different way to write this question. Okay, this is a different way. This is what we call factored form. Okay, so we have 2 different forms here. I'm sorry, so I'm going to erase this. Very tedious process, erasing them. Okay. We have two different forms, and I'm sorry, I wrote x. I should have written b. It should be b plus 1 and b plus 7. Well, again, if I multiply this, if I did b plus 1 times, I did it again, b plus 7, well, again, using what we talked about last week, let's distribute. B times b is b squared. B times 7 is 7b. B times 1 is 1b. I'm going to write the 1 there for now. And 1 times 7 is 7. Well, when we add these two things together, 7b and 1b makes 8b, and we have a way to put back together and take the same thing apart. So depending on your situation, you might want it in this form, or you might want it in this form. It really depends on your situation. If you were graphing these, which is where this is going, you'd want to use this. If you were solving this as an equation, you would want it in this form. So again, we need to be able to, like we said last week, take apart a machine and put back together a machine. So last week we kind of we put it together. This week we're kind of taking it apart. So pretty much to sum it up, does A equal 1? Yes, we can continue. What are my factors of my C term? Which set of those factors adds up to my B term? Okay, so we'll look at a few more examples just to show you guys why it works, though, because remember we were talking about why these things work. Here is my two factors multiplying to make 7, and here's the two of them adding up to make 8. So again, so if you want to know why we're looking for the numbers that multiply to make 7 and add up to make 8, this is why. 1 times 7, right, and 7b plus 1b. So that's why it works. Okay, so I'm going to go through a whole bunch of these examples. Okay, just to kind of get these things clear. You guys should be able to do at least up to number 14, but we're going to do a few of them. Okay, so for number 2, we said that a is equal to 1, so we can continue. So a is equal to 1, we can continue. We want our factors of 10 that add up to negative 11. So let's say, hey, what are my factors of 10? Well, first of all, again, skipping forward, if they have to add up to negative 11, we want the negative numbers. But let's just list them all out. I have 1 times 10, and I have 2 times 5. I have negative 1 times negative 10, and negative 2 times negative 5. Well, 1 plus 10 is 11. 2 plus 5 is 7. Negative 1, negative 10 is negative 11, and negative 2 and negative 5 is negative 7. So these are the set of factors that I want. They multiply to make my C term, and they add up to make my B term. Okay. So now let's write this in factored form. Okay, all factored form. I need two sets of parentheses. I'm going to put my variable here, my variable here. Now, my numbers were negative 1 and negative 10, so I'm going to say n minus 1 and n minus 10. Okay, so again, if you want to check them, n times n squared, n times negative 10 is negative 10n, negative 1 times n is negative n, and negative 1 times negative 10 is going to be positive 10. Okay, so again, if you wanted to check, this is how you can check. Okay, for right now, though, what we should all be doing is focusing on, hey, does A equal 1? Yes, we can continue. What are my factors of C that add up to B? Okay, so again, something everybody can do. You can go ahead, you can identify A, B, and C. 1, negative 11, 10, right? If you're good with that, if you can get that down for all these problems, what are my numbers that multiply to make 10? Okay, if you list those out, hey, which ones those add up to negative 11s? Okay, if you think it's too difficult working with negative numbers, you can pick out a couple of these problems that have nothing but positive numbers. Like say, for example, number 6, or number 10, or number 14. Okay. All right. So number 3 we checked, is A equal 1? Yes. What are my factors of negative 90? Oh boy. Okay. So when you get a big number like negative 90, okay, your best bet is to start small. 1 times 90. Okay. We'll worry about the negative later. Okay. 2 times 45. 3 times 30. Does 4 go into 90? Yes. 4 goes into 90. No, 4 does not go to 90. Does 5 go to 90? Yes. 5 goes into 90 18 times. Okay. Does 6 go into 90? Yes, it does. So if we see, we kind of like watch this pattern here. This number is going up. This set of numbers is going down. So 6 goes into 90. 15 times. Okay, so we're getting closer. Does 7 go into 90? No. Does 8 go into 90? No. Does 9 go into 90? There's you right there. Okay. As you see, these numbers go up, these numbers go down. They've kind of met in the middle here. Now it's negative 90, so let's go ahead and let's kind of make this complicated a little bit. Of negative, 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 right? And then we also have the opposite. We have 1 times negative 90, 2 times negative 45, 3 times negative 30, 5 times negative 18, 6 times negative 15, and 9 times negative 10. Do you want to have to do this every single time? No, and as we get a little bit further, you guys are not going to be writing out all these factors, okay? I want to say that we want the ones that add up to positive 1, so that's going to be this one right here. So negative 9 times negative 10 makes negative 90. Negative 9 plus 10 is going to make positive 1. So what do we got? We're going to write in factored form. Okay, so what do we got? Put our variable first, and we have negative 9, and we have positive 10. Okay, so again, this one, negative 90 obviously has a ton of factors. Again, you guys, as you get further in this, you know if they have to add up to 1, we can skip that one, skip that one, skip that one, skip that one. We're really only going to focus on these kind of factors here. Again, if you guys are understanding this, other things you want to look for, if I add 2 numbers together, and their result is positive, remember the bigger number would have to be positive and the smaller number would have to be negative. Okay? All right. Number 4. A is equal to 1, so we can continue. What are we looking for? We're looking for our factors of negative 12 that add up to positive 4. Okay? So what do we got? We have 1, 12, 2, 6, 3, and 4. Again, as these numbers went up, these numbers went down, they kind of met in the middle. So we got negative 1, negative 2, negative 3, and we also have 1 times negative 12, 2 times negative 6, and 3 times negative 4. Okay, again, since we want a positive number, these are the ones we want. We want the ones with the bigger positive numbers. So this is going to be us right here. So again, what are our factors of negative 12 that add up to positive 4? Negative 2 and 6. Let's write this in factored form. Again, let's take the negatives. Let's take the positive. Okay? All right. Again, what are my factors of 9 that add up to negative 10? Again, so it's positive. So again, we have 1 times 9, 3 times 3, negative 1 times negative 9, negative 3 times negative 3. So which set of these factors adds up to negative 10? This guy right here. So what are we going to do? Factored form, n minus 1, factored form, n minus 9. And again, what are we going to do with this? Eventually, this is going to help us to go ahead and solve equations. Now, number 6 is going to be an important example for us. So let's start off this. What does A equal? What does B equal? And what does C equal? A equals 1, B equals 16, C equals 64. Okay, so what are my factors of 64 that add up to 16? Now, these numbers should kind of stick out to you guys. Again, what are my factors of 64? Well, 64 has a ton of factors. So since we want them to add up to a positive number, we can stick to just a positive ones for now. So we have 1 times 64. We have 2 times 32. 3 doesn't work. 4 goes in 16 times. 5 doesn't go in. 6 doesn't go in. 7 doesn't go in. 8 goes in 8 times. So we can stop right there because our numbers, these are going up, these are going down. Now you'll notice that 8 times 8 makes 64. and 8 plus 8 makes 16. So what are we going to write? We're going to write b plus 8, and then we get another b plus 8. Okay. Well, if I have b plus 8 times b plus 8, let's go ahead and let's write that as b plus 8 squares. This is actually a perfect square. We can actually take the square root of this, which will be very important for us a little bit later, because it's the same thing times itself. Okay? I'm going to go do 7, 8, 9, and 10 maybe, and then we'll call it from there. Okay? So again, a is equal to 1, b is equal to 2, and c is equal to negative 24. What are my factors of negative 24 that add up to 2? Again, we'll take the ones with the bigger positive numbers. This is positive, so we'll say 1 and negative 24. I'm sorry. Negative 1 and positive 24. Negative 2 and 12. Negative 3 and 4. Oops, I'm sorry. And 6. No. Sorry, guys. Negative 3 and 8. Negative 4 and 6, so we can stop right there. So negative 4 times 6 multiplies to make negative 24 and adds up to make 2. So what am I going to get? M minus 4, M plus 6. Okay? Moving across, oh, that actually gave us x's. So again, a is equal to 1, b is equal to negative 4, c is equal to positive 24. Okay, so what are my factors of 24 that add up to negative 4? Again, since they add up to the negative, we're going to rely on those negatives being the bigger number this time. So 1 times 24, 2 times negative 12, 3 times negative 8, 4 times negative 6. And we're looking for the factors that add up to negative 4. So do we have any of these factors that add up to negative 24? No, we don't. We don't. This equals negative 23. This equals negative 10. This equals negative 5. And this equals negative 2. So again, what are my factors of 24 that add up to negative 4? There aren't any. There are no factors of negative 24 that add up to negative 4. Now, are there other factors? There might be. There might be. They just might not be integers. So for most of these, are there going to be things like this? For this one, I don't think there are, but just double check. So again, so we said number 8, not factorable. Not factorable. So the answer is down at the bottom. Okay, so is it possible they're not factorable? Sure. Factorable. Okay. Again, does that mean that we can't solve this or we won't be able to use this? No, it just means that we won't be able to use this method right here. Okay. So continuing, we got a is equal to 1, b is equal to negative 13, c is equal to 40. So a is equal to 1, so we can continue. We're looking for factors of 40 that add up to 13, to negative 13. So the negative will have to be the bigger number. So 1 times negative 40, 2 times negative 20, 4 times negative 10. We got 5, 6, 5. I'm sorry, positive 40. It has to add up to be negative, I was going to say. 5 times negative 8, and we can stop right there. Okay, so negative 5 times negative 8. Okay, so again, see, it's positive 40, so what are my factors? Then multiply to make 40 and add up to make negative 13. X minus 5, X minus 8. Okay, last one. A is 1, B is 11, C is 18. Again, don't get this A confused with this A. They're not the same thing. Okay, so what are my factors of 18 that add up to 11? Again, so everything's got to be positive here. So 1 and 18, no. 2 and 9, we can stop right there. But we'll just do these for the sake of doing them. 2 and 9, so what are we going to say? A plus 2, because it's positive, and A plus 9. Okay? So tonight, if you guys want to practice a few of these, you can do 11, 12, 13, 14. We'll talk about what we're going to do with these other ones. You guys can do 18 if you want. Anything where a is equal to 1. 19 you guys can do. Okay? And check your answers down at the bottom. Okay? So all the answers are here. You guys have to be grown-ups about this. We'll talk about what you're going to do. So again, you should be able to do all these. I hope all you guys are staying safe out there. I hope this is helpful. If you have specific questions, please, pretty please, email them to me and I will get back to you as soon as I can. Thank you.